f of x is equal to sine of x minus 30 degrees, and g of x is equal to sine of 2x degrees. And it says for which values of x is f of x equal to g of x. So you will agree we actually are solving the equations, or rather the equation sine of x minus 30 degrees is equal to sine of 2x. And we need x for that. But for this particular equation, can we solve for x between 0 degrees and 360 degrees? So we're looking for the particular solution for x from 0 degrees to 360 degrees. So the graph would look like that, and we are looking for the values of x from 0 up to 360, for which these graphs are equal. And you will notice one of the points is there, and the other point should be somewhere there. Is there another one? Possibly. There are two more. Do you see that? Okay, I can see there is one more here. They're equal there, and they are equal there. So we're expecting about 4 answers. So sine of x minus 30 degrees is equal to sine of 2x. It helps to look at the sign, like positive or negative. Like in this case, there is a plus sign there in front of sine of 2x. I'm just focusing on that one. I could have focused on the other one. And the good thing is, on the left-hand side, we've got a sign ratio. And on the right-hand side, we've got a sign ratio as well. The one on the right-hand side is also positive. So we can think of all answers where sign is positive because of the plus sign that is in front there. So can we obviously get our answers from the first quadrant and the second quadrant, because that is where sign is positive. If you are using this, then we could say the reference angle is equal to 2x. So just accept that that 2x there is kind of your reference angle. And our answers are in quadrant 1 and in quadrant 2. So from quadrant 1, remember that is like 2x. What is x minus 30 equal to? X minus 30, we're measuring from 0 degrees, right?
2x plus k.
So we can say x minus 30 is equal to 2x plus k 360, okay, plus k 360 degrees. We can simplify that. I think that will give us all the angles from quadrant number 1. So let's simplify that. Bring the 2x maybe to the left-hand side. That should give us negative x, and then move the negative 30 to the other side, so that gives us positive 30 degrees. All that plus k 360, and k is an integer. Then you can find x from there. So that will be negative 30 degrees, subtract k 360 degrees, where k is an integer. From quad 2, we need all that angle there, that whole angle there. So what is x minus 30 degrees equal to in quad 2? That should be 180 subtract. Okay, 180 degrees subtract 2x plus k 360, right? Okay. Okay, then let's solve that for x. So bring the minus 2x to the other side. You will get 3x. Take the negative 30 to the other side. Is it 210? So get 210. All that plus k 360 degrees, where k is an integer. Then we can divide by 3 to get x. So x is equal to, is it 70 degrees? 70 degrees plus k 120 degrees, where k is an integer. But we are looking for answers from 0 degrees up to 360 degrees. So now let's substitute. If you put k equal to 0, let's do that for both of them. What do we get for x if k is equal to 0? Let's start with the first one. Do we see that if k is 0, we'll get a minus 30 there? Do we need minus 30? No. So I don't have to worry about that. But in the second one, if I put k equal to 0, I get 70. So 70 degrees is within the range. We want that. Okay, that is for k equal to 0. What about for k equal to 1? What is x when k is 1? If I put in the first one, k equal to 1, will that help me? No. In the second one, put k equal to 1. We get how many? I think 190. Huh? Okay, we get 190 degrees. All right. So that is 190. Let's try negative 1. Let's try negative 1. In the first one, if I put k equal to negative 1, we end up with 330, right? Okay, so we need that. So x will be equal to 330 degrees. What about in the second one? If we put k equal to negative 1, does it work? It doesn't help us. Okay. Right, let's go to k equal to 2. Put k equal to 2 there. Will it help us? No, it won't. Put k equal to 2 in the second one. We get 240 plus 70. What is, how many degrees? 310. So 310 degrees. Okay, negative 2?
Yes, it does.
Negative 2, I think this would be 720 minus 30. I think that's beyond 360. Then negative 2 here gives us a negative. So we are done, right? So this should be the four values of x. Now, this equation, sine 2 theta, is equal to cosine of theta minus 50 degrees. We want the general solution. Please take notes. We have two ratios here. So this is a mixture of two ratios, sine and cosine in one equation. Right, and we cannot divide and change that to tan. The reason is because the angles that we are using there are not equal. So 2 theta and theta minus 50 are not equal, so we cannot divide and change that to tangent. But if this was sine of 2 theta, and maybe that was cosine of 2 theta, then we could change everything to tangent of 2 theta. Because sine and cosine are co-functions or co-ratios, we can actually change one of them. Like if we want, we can change sine 2 theta and write it as cosine of something. Remember that two angles that add up to 90 degrees are complementary. So we can change sine 2 theta to cosine of something. If we want, we can change cosine of theta minus 50 and make it sine of something. So it's up to you. Which one do you want to change? You want to change cosine. Let's change cosine. So in other words, let's leave sine of 2 theta as it is. But instead of cosine, we want to change that one to sine. Now please tell me what angle we use there. If we change it to sine, we need to take that theta minus 50 and minus it from 90 degrees, right? So this becomes negative theta plus 140 degrees. So let's go back to sine of 2 theta is equal to sine of that angle there, which is negative theta, plus 140 degrees. Right, even without using the quadrants, what do you think 2 theta is equal to? If this is sine and that is sine, then 2 theta should be equal to that angle there, right? As it is, right? So that is minus theta plus 140 degrees. Okay, but we can add as many 360s as we want, where k is an integer. Move the negative theta to the other side, so we get 3 theta. So 3 theta is equal to 140 degrees plus k 360, where k is an integer. 46.67 plus k 120. Okay, thank you. That is just one solution. If you remember what we said last time for sine, there should be another value for 2 theta. 2 theta was equal to this thing here. So 2 theta was equal to that thing there. That is an angle. If it's sine, do you remember that the other angle should be 180 subtract the one angle that you have. So if this is one of the angles, then the other one should be 180 degrees subtract that whole thing there. Obviously, plus k 360 degrees. K is an integer. Then simplify your word. I think if you simplify that, you should get theta is equal to 40 degrees plus k 360, where k is an integer. So for this one, cosine of x is equal to negative cosine of 2x. We should be happy because it's cosine and cosine both sides, right? Okay. And so when you get something like this, the negative that you see in front there is suggesting that we should work with the quadrant where cosine is negative. And we must stick to maybe 2x as our reference angle. So I'm thinking 2x is our reference angle because of the minus where is cosine negative. Quadrant 2 and quadrant 3. Right. Okay, so from quadrant 2, remember this is 2x. From quadrant 2, what is x equal to? 1x, sorry, x is equal to 180 minus 2x, right? Okay, plus k 360. Right. Let's simplify that. So that is 3x is equal to 180 plus k 360 degrees. And so what is x equal to? 60 degrees plus k 120 degrees, or k. Right. Then from quadrant 3, this is where we are, and we are saying that is 2x. If we move like this, we get to quadrant 3. What is x equal to? Now it's 180 plus 2x plus k360. That would be the answer.